Alright, welcome back everybody. In this video we're going to talk about compound probability and events again, only this time we're going to talk about when the two events that are involved in the compound probability, or more, are dependent. And what dependent events are is they are events where the probability of one event occurring changes the probability of the other event occurring. And when we have two dependent events to find the probability of A and B, notice this is similar to what we did with independent events. We take the probability of A and we multiply it by the probability of B given that A has occurred. So once we know that A has occurred, that changes the probability of B. And so instead of just probability of A times probability of B, like we had with independent events, we need the probability of A times the probability of B, given that A has already occurred. Let's take a look at a couple of examples to solidify this idea. Here's the first example. Jaquan has a bag of ping pong balls. There are 6 yellow balls, 4 green balls, 3 purple balls, and 7 red balls. If he reaches into the bag and pulls out 2 ping pong balls, what is the probability that? And then we'll answer all of these questions. Now, first off, realize that when he pulls out 1 ping pong ball, or pardon me, 2 ping pong balls, what's really happening when he does that is he's pulling one out and keeping it, and then pulling another one out. That's what it's really equivalent to pulling 2 ping pong balls out of this bag, is like pulling one out, keeping it, and then pulling a second one out. So first of all, the first thing I'm going to do to calculate these probabilities, I'm going to see how many total ping pong balls there are in the bag. There are 20 ping pong balls in the bag to start with. Okay, so to pull out 2 and have both be red, first he has to pull 1 red ball out of the bag. And there are 7 red balls in the bag. So the probability of pulling out a red ball as the first ball is 7 out of 20. Now when he goes to pull that second ball out of the bag, there aren't 20 balls left in the bag anymore. There are only 19. And there aren't 7 red balls in the bag anymore because we've already picked up that he pulled a red ball with the first ball in order for both of them to be red. So there are only 6 red balls left in the bag. And so to find this probability, the correct calculation is going to be 7 over 20 times 6 over 19. And so we'll go ahead and do that. 7 over 20 times 6 over 19. I'm going to go ahead and convert that over to a fraction. And that's 21 over 190. Or if you want to write it as a decimal, we already found that it is 0.1105 or 11.05%. Any of those 3 probabilities would be okay, for both are red. Alright, both are purple. Okay, so the chances of pulling a purple one on the first ball is 3 out of 20. There are 3 purple balls out of the 20 in the bag. And then to pull the second ball out, there are now only 19 balls left in the bag, and 2 of them are purple. And so we'll go ahead and calculate that value. 3 over 20 times, times 2 over 19. Change that over to a fraction. That's 3 out of 190. So not very likely. Or as a decimal, 0.01579. 0.1579, or 1.58%. All right, next. Probability that he pulls out a red, then a green. Okay, so the probability that he pulls out a red is going to be 7 out of 20. 20 balls in the bag, 7 of them are red. And then a green. Now there's only 19 balls left in the bag. And how many of them are green? Well, there's 4 still. And then we'll go ahead and calculate that. That's 7 over 95. Or as a decimal, 0.0737. Or as a percent, 7.37%. All right, part D. He pulls out a red and a green. Notice the difference between this and part C. In part C, he pulled out a red first and then a green second. In this one, he's pulling out a red and a green, which means he could pull a red first and a green second, or he could pull a green first and a red second. And so we want to find both of those individual probabilities and add them together to get the probability that he pulls out a red and a green. So first, I use the probability that I had from the previous part of getting a red and then a green. And I'm going to add to that the probability of getting a green, pulling out a green first, and then a red. All right. Now, if you understand the way that fractions work, you'll notice that when we multiply these together, this probability and this probability are going to be equal to one another. So really, I can just double one of these probabilities to get the probability of pulling out a red and a green. We already calculated back here, we already calculated that probability. So I'm going to take 2 times 7 over 95, which is just 14 over 95. So notice the difference between those two scenarios, red then a green, red and a green. With the red and a green, there's 2 different possible ways that I can get a red and a green ball out of the bag. All right. And you can calculate the decimal and percentage for that if you want to. I'm just going to bypass it since I'm out of room and go on to the last example. All right. Caleb has a bag containing 3 packs of peanuts, 4 packs of almonds, and 2 packs of cashews. If he randomly picks out 2 packs from this bag, what is the probability that? First, both are peanuts. Well, to pull the first bag out, or the first pack out, there are 3 packs of peanuts out of the 9 packs in the bag. And then if he already pulled out a pack of peanuts, there are 8 packs left, and 2 of those packs are peanuts. So we'll calculate that. 3 over 9 times 2 over 8. We get that that's 1/12. And again, you can calculate the decimal and the percentage if you want to. I'm just going to leave it as such. The probability is 1 in 12 that that's going to happen. Okay, next, the probability that both are cashews. To pull out cashews first, it's got a 2 in 9 probability. And then after he's pulled out 1 bag of cashews, or 1 pack of cashews, there are 8 packs left, 1 of which is a cashew. We go ahead and multiply that out, and that's just going to be 1 in 36 probability. All right, part C, he pulls out peanuts, then cashews. So to pull out peanuts first, it's 3 out of 9. Once he's pulled out a pack of peanuts, there are 8 packs left, 2 of which are cashews, and we already did that calculation in part A. So the probability of that is 1/12. And then the second one, he pulls out peanuts and cashews. Again, there's 2 ways to do this one, to pull out peanuts and cashews. He can pull out peanuts first and then cashews, or he can pull out cashews first, which is 2 out of 9, and then peanuts. And again, we're just doubling the probability that we found here in part C. We've got that probability, and then we've got another probability that's equal to it. So we're just doubling that. So it's really 2 times 1/12. And the probability of that is just going to be 1/6. Again, like I said, you can find the decimals or for the percentages for those if you like. I just wanted to focus on how we actually calculate them. All right, and that's how we handle compound probability and statements when the events are dependent. You've seen pretty much all the different kinds of examples that I can do with these particular problems in this video. So that's going to be the end for today, and we'll see you guys next time. Have a great rest of your day.